Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, QMD, a mini CLI search engine that lets you search your docs, knowledge bases, and meeting notes entirely on your local machine. It tracks the latest state-of-the-art retrieval approaches while keeping everything private and offline, making it a compelling solution for developers who want powerful semantic search without sending their data to the cloud. What if the most sophisticated search engine you have ever used ran entirely on your laptop, cost nothing, and never sent a single note to a server? A project called QMD launched recently and crossed 9,000 stars on GitHub. It is fueled by a remarkably bold promise: enterprise-grade hybrid search for your personal Markdown files. No cloud required. The technical architecture hiding behind that simple command line interface is worth examining closely. QMD stands for Query Markup Documents. It is a local CLI search engine built by a developer named Tobi, designed to index and search personal knowledge bases, meeting transcripts, technical documentation, and anything else stored as Markdown files entirely on the user's own machine. The project is written in TypeScript and currently sits at 9,080 GitHub stars, with 258 added in a single day and 492 forks. Those numbers suggest it hit a nerve in the developer and knowledge worker communities. What makes that traction even more interesting is the context. This is not a startup product with a marketing budget behind it. It is a command line tool solving a problem that many developers have quietly accepted as unsolvable without a cloud service. Personal knowledge management tools have a fundamental search problem. Apps like Obsidian, Logsec, and raw Markdown vaults accumulate thousands of notes over years. The built-in search in most of these tools is keyword-based. So, if you wrote about cost reduction in a note, but you now search for budget optimization, you get nothing. The vocabulary gap between how you wrote something and how you later remember it is a persistent source of frustration. The existing workarounds are unsatisfying. Traditional tools like ripgrep and FZF are fast, but purely lexical. They match characters rather than meaning. Cloud services like Notion or Algolia offer semantic search, but they require uploading your data to external servers, which is a non-starter for anyone with sensitive notes. Local vector database setups like ChromaDB or Qdrant exist, but they require significant configuration and still leave users building their own query pipeline from scratch. QMD takes the position that the entire problem should be solved end-to-end, locally, with a single install command. The technical architecture of QMD is where things get genuinely interesting. Under the hood, it runs a multi-stage hybrid search pipeline that combines three distinct retrieval approaches. The way it fuses them together reflects real depth of design thinking. The pipeline begins with query expansion. Rather than taking your search phrase literally, QMD feeds it through a fine-tuned 1.7 billion parameter local language model, producing two alternative phrasings of your query. So, a search for quarterly planning process might internally expand to something like annual roadmap review and strategic resource allocation. This addresses the vocabulary gap problem before retrieval even begins. Those three query variants, the original and two alternatives, are then sent in parallel to two separate search backends. The first is BM25 full-text search, a classic probabilistic keyword ranking algorithm running on SQLite's FTS5 extension. BM25 is fast and excellent at exact term matching. The second backend is vector semantic search, running on SQLite, which finds documents based on conceptual similarity rather than literal word overlap. The results from 6 retrieval runs, 3 queries times 2 backends, are then merged using an algorithm called reciprocal rank fusion, or RRF. Think of RRF as a voting system for search results. Rather than trying to normalize scores across incompatible scales, it simply counts how highly each document ranked across all the lists and combines those ranks into a single score. QMD adds a refinement here, giving the original query twice the weight of the expanded queries and applying small score bonuses to documents that ranked first in any individual list. The top 30 candidates then go through LLM re-ranking using a Qwen3-based cross-encoder model running locally. Unlike an embedding model that compares query and document in isolation, a cross-encoder reads both simultaneously, producing a much more accurate relevance judgment. The final step is called position-aware blending, and it is the most distinctive design choice. Rather than fully trusting the re-ranker, QMD dynamically mixes the RRF score and the re-ranker score based on where a document originally ranked. Documents in the top 3 positions get 75% of their score from the retrieval stage, preserving high-confidence, exact matches. Documents ranked 11th and beyond get 60% from the re-ranker, trusting its deeper analysis more heavily for uncertain results. This prevents the re-ranker from accidentally burying an exact match simply because it also appeared in unrelated contexts. All 3 local models, the embedding model at 300 megabytes, the re-ranker at 640 megabytes, and the query expansion model at 1.1 gigabyte, are downloaded from Hugging Face on first run and cached locally. The practical entry point is deliberately simple. Install QMD via npm or bun, point it at a directory of Markdown files, run the embed command to generate vector indexes, and you are ready to search. The 3 search modes expose different layers of the pipeline. The search command runs bm25 only, which is nearly instant and works well when you remember the exact phrasing. The vsearch command runs vector search only, useful for conceptual lookups. The query command runs the full hybrid pipeline with re-ranking, delivering the highest quality results at the cost of a few extra seconds. For developers building with AI agents, the output options are particularly relevant. Passing flags for JSON or file output produces structured results designed for consumption by a language model. The built-in MCP server, using the Model Context Protocol standard that tools like Claude support, allows an AI assistant to call QMD directly as a tool, querying your private notes without any data leaving your machine. A researcher maintaining a large Obsidian vault, a developer juggling documentation across multiple projects, or an engineer who wants to give a local AI agent access to internal company notes without a cloud dependency, these are all natural fits for this tool. Community reception has been clearly positive. On Hacker News, developers described QMD as a meaningful upgrade over FZF-based workflows, specifically calling out its ability to handle fuzzy conceptual queries that traditional tools miss. Several users drew comparisons to Obsidian's built-in search, noting that QMD catches semantic connections between notes that keyword search simply cannot surface. Discussion threads gravitated toward a few recurring questions: how the tool handles very large vaults with hundreds of thousands of files, how it compares to running a local Qdrant or ChromaDB instance, and whether the MCP integration is stable enough for daily use with Claude Code or Cursor. Notably absent from those discussions is any significant criticism of the core approach. The main open questions are practical ones, about scale and performance on specific hardware configurations rather than skepticism about the architectural choices themselves. The hybrid search pipeline is genuinely sophisticated, but sophistication introduces fragility. The quality of QMD's results depends on 3 separate local models staying appropriately tuned relative to one another. If the embedding model and the re-ranking model have different notions of relevance, the position-aware blending logic may not compensate correctly. Fine-tuning a custom query expansion model is also a significant ongoing commitment. As the underlying base models in the broader ecosystem improve, maintaining alignment across 3 separate model components becomes an increasingly complex maintenance burden for a solo project. There is also the hardware reality. Running 3 models in sequence adds up. On machines without dedicated graphics processing, the full hybrid query mode may feel sluggish for large vaults. The promise of a completely local search engine is most compelling precisely for users with sensitive data, and those users may be running older or less powerful hardware. Whether QMD evolves into a broadly adopted standard or remains a well-engineered niche tool may depend less on its technical merit and more on whether the developer can sustain active maintenance as the local language model ecosystem continues moving quickly. QMD represents a meaningful shift in what is possible for personal knowledge search. It delivers a search experience that previously required cloud infrastructure, packaged into a tool that installs in seconds and keeps every byte of your data local. For developers and knowledge workers who have quietly tolerated mediocre local search for years, it is a serious and technically credible alternative worth evaluating immediately.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.